Alright, so we have a car traveling very quickly. It slams on its brakes and skids to rest. And we've got a skid mark, which is the distance it takes to stop. And we have a braking acceleration. We want to know the speed and the time it took to come to rest. So we'll start our position at 0. We say that we end at 40 because that's the time we take to skid. Now, since we're moving forward and the brakes want to drag us in the opposite direction, we're going to make this -2 meters per second squared because it's a braking acceleration. And then V0 is going to be unknown, and we actually end up at rest. And our time is unknown. So we want the initial velocity before the driver slammed on the brakes, before they driver. Very good spelling, yes. All right. So we have V squared is V0 squared, because I don't have time. That's why I'm grabbing this formula. Times x minus x0. Let's put in our numbers. So 0 squared equals the thing that we're solving for, plus 2 times -2 times 40 minus 0. So we're going to end up getting 0 equals V0 squared minus 160. We'll add 160 to each side. And that's going to give us 160 as v squared, or v0 squared, the initial velocity squared. When we actually work that out, let's just go ahead and do that now. So the square root of 160 is 12.65. And that's meters per second. Now let's go ahead and get the time it takes to stop. So that's going to be V equals AT plus V0. That's 12.65 from here. Sorry, that's really badly written. Oh, whoops. Well, I got to redo that. Whoops. Yeah, let's try to fix that. So again, $12.65 equals 2 times t plus 0. We'll divide both sides by 2, and that's going to give us a time of about 6.32 seconds to stop. All right, so that's question number 6. And in the last video, I'm going to take a look at the honors question. Honors students, I'm going to be using a little bit of a different approach here, so take a look at that video. But that's questions 1 through 6. That is our practice test.